In this demonstration here, I would like to show how to create a new project in ARTeMIS Modal. What we'll do is we will upload some data, we will create a geometry, and we will also assign where the different channels are located on this geometry. Then in later demonstrations, I will show how to process the data and also do the actual modal analysis. But for now, we will start creating a new project. What I'll do is I will use this dialog that appears when you start up ARTeMIS Modal, this welcome dialog. There is an item here called Create New Project, and I will click this item here and I will select the internal storage mode. That is the one that you will normally use for simple projects where you are only analyzing a single test. Then I click Next, and then I have three options: either to use a blank project, use a configuration file, or use universal file format. The blank project will create as it says, blank project. If I use the configuration file, I will use the so-called SVS configuration file. That is a text file that includes the different information needed in order to initialize a project. I can also do the same from universal file format if I have both my geometry and my measurements defined in this particular format. In this case here, we will use the blank project item and click Finish. I'm now inside the project that has been initialized. I'm inside a particular task called Manage Measurements. This task here is one of the setup tasks that we can find up here by clicking here. We can see we have different tasks that are related to the initialization of a project. What I'll do now is I will go to the first task, the Prepare Geometry, where we will then create a geometry of this structure that has been tested. The structure is a plate, aluminium plate, that is a little bit rectangular. It has been tested with 16 channels that has been located in a 4x4 grid. What we'll do here is we will generate a simple drawing of this plate here, and I do that by selecting this item up here. I have different predefined objects that I can choose between. What I'll do is I will use the cube object here that I click on to insert. Now I take my mouse here and I drag it down to one of the corners I have of this plate that I want to draw. Then I press my mouse button and I start dragging this mouse here to the other corner of the plate. I release the mouse and now I can move it up and down to get the thickness of this plate here as I want. When I'm there, then I click one more time, and then I have my plate object defined, as you can see. What we are missing now is that we in fact only have 4 corner nodes here. We are missing nodes in between here where we can mount the sensors that we are going to upload later on. So what I'll do now is I will make a subdivision of this structure here. I have dividers here. I can choose, instead of having 1 divider, then I'll have 3 in the X direction and the same in the Y direction. And when I update now, then we see how we now get additional points put on this structure here. And this is enough for now. We have all the points we need in order to assign the 16 measurement channels. So what I'll do now is I will switch to the next task, the one we were starting out from, the Manage Measurement task. Now I need to upload data that I can assign to these different points I have on my geometry. I do that by going to this data organizer tree here. I activate the upper item here, and then I insert a new test setup. I do that by clicking the first button here. Now I have this empty item here where I can then import my measurement channels too. And I do that by clicking this open dialog button here. That allows me to find the data file somewhere on my computer. I have a folder here with some data from this particular plate here. I have different file formats to choose among, as you can see here. The one I'm going to use here is the SVS binary file format. So I select this one here, and now I get a file that I can now upload. So I click open, and then it uploads the file, and we are now renaming then this setup label we had up here to the name of the file in this case here. We can see now the measurement records here from the different channels. We have some statistics over here that allows us to get a quick evaluation of this data here. What we need to do is we need to modify the time scale. As we can see, it's not correct. It's supposed to be up to 60 seconds. The reason is that this particular file format here does not have any information about the sampling interval. So what we do is we insert this by clicking this parent item here again. Now we can insert either the Nyquist frequency, the sampling frequency, or the sampling interval, depending on what we know. I know that the Nyquist frequency is 2048 Hertz, like this. And when I go back now to the data, then we can now see that we have up to the 60 seconds as expected of data. What we need to do now is we need to associate the different channels here with the node where they have been located in, or should be located in this analysis here. We do that in the third task we have in the setup part here. This is called assign DOF information. So if I select this one here now, I will get a larger version of this geometry that we have been drawing. And then I get my list of the different channels over here, and you can see that all of them are red right now. That means they have not been connected to any points. What I do now is I will simply grab hold of each of them. I will take the first one here, and then I start dragging it. So I drag it now down to the first node here where it's supposed to be, and then I release the mouse. I will do exactly the same for all the other channels, so that we get them to cover the whole geometry here in a 4x4 grid. So here it's important to know the measurement sequence that these channels has in fact been put in on the real structure when it was tested, because otherwise we will not get correct mode shapes, of course. So in a few seconds we are all the way through all the 16 channels, and we are ready now. So what we have now is we have a project that has been initialized. We have the geometry, we have the data, and we have the association between this. The DOF information has now been added to each of these channel objects. They know where they are sitting, and they also know in what direction they are pointing. If needed, we could, for example, change the direction of some of these channels here. It could be this channel here that we have currently selected. If it was not supposed to be in the Z direction, we can select one of the other directions in this little toolbar here, for example, like this, where we'll get it in the X direction or the Y direction, or again back in the Z direction. If we have more complicated directions to add here, then we can actually go here to this particular entry here, and then we can specify the directional vector of this particular channel. But in this case here, all of them are pointing in the Z direction, which means that we are now ready to switch to the analysis part, where we can then perform the required data analysis and of course the modal analysis after that. That was the end of this demonstration here. Thank you.